Today, we are embarking on a fascinating journey into the realm of network topologies and the indispensable principles of designing them with security in mind. I'd like to thank each one of you for joining in, and I promise this will be both enlightening and engaging. Today's topic, network topologies design principles, isn't just about understanding how networks are structured but, more crucially, how they can be structured safely. Let's unravel this together. When we speak about designing with security in mind, it's more than just implementing firewalls and restricting access. Think of it like building a house. While aesthetics, comfort, and functionality are all essential, the fundamental question we ask is, how safe will my family be in this house? Security, in the context of networks, is not just an add-on but the very fabric that weaves our design together. It's about foreseeing potential threats, being a step ahead, and ensuring that even if one line of defense fails, we have other layers to fall back on. Key principles in secure design. In our quest for a robust network, we lean on 4 sturdy pillars: limiting access. Just as you wouldn't give the keys to your home to a stranger, we ensure only trusted entities can access our network. Layered defense. Much like a castle with outer walls, inner walls, a moat, and guards, we deploy multiple layers of defense to deter intruders, compartmentalizing the space. In case of a breach, the intruder finds themselves in a maze. Our data and services are segregated, much like the different chambers in a fortress. This makes it much harder for an adversary to navigate or do extensive damage. Regular vigilance. And just as a watchtower keeps an eye for incoming threats, we continuously monitor and update our systems to fend off new vulnerabilities. What is DMZ? Imagine the space between the outer walls of a castle and its inner sanctum. It's called the demilitarized zone or DMZ in network parlance. It serves as a neutral space, where we can interact with external entities without directly exposing our internal, more secured assets. DMZ ensures that even if an invader climbs the outer wall, or in our case, hacks a public-facing service, they're still miles away from the throne room or the heart of our operations. Working of DMZ. Let's journey through the DMZ. When someone from the external world, say the internet, wants to access a service, they first knock on the doors of the outer firewall. This gatekeeper is stringent and only allows specific types of requests to pass. Once through, the user can interact with the services in the DMZ. But here's the catch: if they wish to get to the inner network, they face another even more strict firewall. It's like navigating through multiple security checkpoints, each one more stringent than the last. Example of DMZ. To illustrate, imagine a museum. The most precious artifacts aren't usually placed near the entrance. Instead, visitors first encounter less valuable items. As they journey deeper, passing through various corridors and security checks, they get to the heart of the museum where the crown jewels lie. Similarly, our core data and services are nestled deep within, shielded by the DMZ from the prying eyes of the outside world. What are subnets? Now, within our fortress, we don't just have a random assortment of rooms. We have organized sections, chambers for royal family members, kitchens, armories, and libraries. In the world of networks, these are our subnets. They allow us to compartmentalize our resources, segregating them based on function or department. This organization does more than just bring order, it elevates security and performance. Working of subnets. Imagine a bustling castle. The scholars in the library don't want to be disturbed by the clanging in the armory. Subnets ensure this segregation. Each room or subnet manages its traffic, its policies, and its access controls. They act as individual entities under the larger network umbrella, making sure that issues or vulnerabilities in one area don't disrupt the operations in another. It's a fine-tuned ecosystem that maintains harmony within the network. Example of subnets. Consider a university campus. The physics department, literature section, sports complex, and administrative block each has its space. The chaos of a sports match doesn't disrupt a researcher doing a delicate experiment. Similarly, in our network, the marketing team's promotional activities won't slow down or jeopardize the financial transactions of the accounts department, thanks to subnets. What are VLANs? VLANs, or virtual local area networks, are like magic chambers within our castle. They can make members feel they're in the same room, even if they are physically located in different wings. VLANs give us the power to group devices by function or team, irrespective of where they are physically situated. It's like having a virtual meeting room where all key members can gather, even if they're continents apart. Working of VLANs. In our dynamic fortress, sometimes members of the council need to gather swiftly. They can't be running from one end to another. VLANs facilitate this by creating a virtual space where these members feel interconnected. In technical terms, a device in the finance team on the ground floor can seamlessly communicate with another finance device on the top floor, as if they're adjacent. It's the art of making the physical layout irrelevant and prioritizing logical groupings. Example of VLANs. Imagine a university. Students, professors, and the administrative staff each have their own domains, even if they're physically intermingled. It ensures the dean doesn't accidentally stumble upon a student's game night invite. I'd like to express my gratitude for your attention and engagement. In the vast world of networks, remember, safety and efficiency go hand in hand. Here's to building safer, smarter, and more resilient networks. Thank you, until we meet again.